have a big show for you tonight.
You need to know that we've been spoiling you a little bit up to this point involving quadratic equations, because so far we've only given you problems that contain factorable expressions. So you could use the zero property. Well, you're not going to be able to use that for all of them, because most equations you actually cannot factor. So I'm going to have to give you a couple of ways to solve a quadratic equation when you can't factor the expressions involved. And that leads us
And now to something completely different.
to rooting both sides. That's one of the methods we'll use. Okay? Let's take a look.
And I want to show you that it's always something.
Now we know when we have a quadratic equation, we're supposed to get two answers, aren't we? Well, if we take this, and it really is a quadratic equation because it has an x squared,
Certainly.
we can square root the x squared, and what will that do? That will undo the x squared. If we take the square root of the other side to be fair, we'll get 7. Or will we? We're supposed to get two answers. But remember, when you take a square root, you get two answers, plus 7 and minus 7.
Hey, you're plumb right, Barman.
So it works. Now that one came out real nice, actually, and if I had subtracted 49 from both sides, I would have been able to factor. What if I can't factor?
Played it for her, play it for me. Play it.
See, it'll still work. We get an equation like this. Of course, we should get two answers, and we will. What will we do to undo the squared? We'll take the square root, and that'll get us the x because it undoes the square. Now on the right side, we also will square root,
So why don't you fix it, meathead?
but we have to, since it's not a perfect square, we have to simplify it into, what if you would, perfect squares and what's left over. Square root of 16 is a perfect square, but we still get two answers because anytime you take a square root, you get a plus and a minus answer.
Get on before somebody knocks the house on you.
Okay? Now, I want you to understand we're going to add a little bit more to these problems. And let's review the order of operations because all of algebra is based on the order of operations. When we do a problem, if you would, you know we do parentheses, then exponents, then multiplication and division left to right, then addition and subtraction, and then we simplify any fraction. That's when we do a problem. But you know what? When we're solving an equation, we're actually undoing a problem. So when your teacher told you you needed to know the order of operations forwards and backwards, they weren't kidding, because we're going to use the order of operations backwards to solve equations, to undo them. We're going to get rid of,
Excuse me?
first of all, we're going to get rid of fractions. We haven't covered that yet, but that's the first thing we're going to do if we see a fraction in an equation. Then we're going to get rid of any additions and subtractions that are keeping x from being alone. Then multiplications and divisions. And then the last thing we're going to do is get rid of the exponent, 2. Okay? And remember, our new tool to get rid of at least the exponent 2 is the rooter.
And away goes troubles down the drain.
Let's take a look at one. Okay, now that x is surrounded by a bunch of enemies. We have to get rid of the 3, we have to get rid of the 2, and we have to get rid of the minus 5. And we're going to use the order of operations backwards to get rid of them all. Who do we get rid of first? And remember, we're going to have two answers. Who do we get rid of first? We're going to get rid of the subtraction first with addition. We do it to both sides. Now, working backwards through the order of operations, we're going to get rid of the 3, who's multiplying. So I do the opposite and divide. Now I'll get rid of the 2, who's an exponent, with the rooter. That undoes the square.
And away goes troubles down the drain.
And don't forget, when you use the rooter, you get 2 answers. Okay, so the answer to this equation was plus n minus 4.
Oh, good grief.
Now this one's very different. We're going to work our way from outside in. We're going to get rid of the exponent first because remember, parentheses in the order of operations come before exponents. So let's get rid of the squared first.
Whoa!
Okay?
That's the fact, Jack!
We're going to have 2 answers here, but we're going to take the square root on both sides.
And away goes troubles down the drain.
On the left side, the square root of x plus 2 squared is just x plus 2 because it undid the square. On the right side, well, we just have to write the square root of 11, but we need to remember that there's going to be 2 answers, and the square root yields 2 answers. It seems like I'm repeating it, but that's one of the more common mistakes that people forget. Okay? That's where the plus or minus goes with the square root. Now all we have to do is get rid of the 2, who doesn't get a plus or minus. He's a minus. Okay? And on the left side, you'll have just x. And on the right side, we'll have 2 answers. Negative 2 plus the square root of 11 and negative 2 minus the square root of 11. Our answers are going to start looking ugly like this when we couldn't have factored in the first place. Okay, this is going to be an irrational answer, I hope you appreciate.
That's the fact, Jack!
And there are 2. And you could actually get an estimate of either of these 2 answers by putting into your calculator negative 2 plus the square root of 11 and hitting enter, and then putting in negative 2 minus the square root of 11 and getting in, and hitting enter.
Believe it or not.
Okay, let's try one more. It's a little bit more difficult. Don't let it scare you. What are we going to do? We're going to get rid of the squared first, work our way from outside in. How do we get rid of a squared? Use your toolbox. Square both sides.
And away goes troubles down the drain.
Okay, seems reasonable. On the left side, we'll have just 3x minus 5 because we undid the squared. On the right side, we've got the square root of a negative number. You actually can't get an answer to that because it's the square root of a negative number is an imaginary number because it involves the square root of negative 1 or I. So we'd get basically the square root of negative 36 is 6i, but it has 2 answers. Plus or minus 6i. Okay? Now all we have to do is get x alone. Add 5 to both sides. And we'll get 3x on the left side and 5 plus or minus 6i on the right. Now, divide to get rid of the 3. And x will equal 5 plus 6i over 3 and 5 minus 6i over 3. That is 2 answers, okay? This is but it is 2 imaginary answers, but it is 2 answers, and that can happen.
Alrighty then.
Well, you need to go practice this.